Okay, now we're going to talk about other types of functions. You've been exposed to all of these, but I guess we're going to need some practice. So pay real close attention, make sure you do your checkpoints, and we will follow up in class. Make sure that you write down any questions that you have, your burning questions, so we can go over them in class. All right, here we go. So the first thing we're going to do is solve a polynomial function by factoring it. And our first example is going to be 3x to the fourth minus 27x squared. I'm going to stop right now and tell you the temptation here would be to divide through by x squared. You can't do that. You can divide through by a constant but not by a variable, and the reason for that is you'll lose a possible answer. So what we're going to do is, first of all, we're going to set the equation equal to 0. So this would give us 3x to the fourth minus 27x squared equals 0. Now we're going to factor, and if we can pull out a 3x squared, so we have 3x squared times x squared minus 9, and then we're going to set each factor equal to 0. So we have two factors. We have our 3x squared and we have our x squared minus 9. So 3x squared equals 0 means x equals 0. X squared minus 9 equals 0 means x equals plus or minus 3. So it looks like we have three answers to this, which is 0, 3, and minus 3. You really need to plug those numbers back in to make sure they work. I'm not going to do it. I will tell you that they do work. Remember, when you're taking a quiz or a test or whatever, you know I'm always going to be looking to trip you up. So make sure that you check that out for those extraneous answers. Okay, go ahead and do checkpoint number 1. Next, here's another example, example number 2. X cubed plus x squared equals 4x minus 4. So the first thing that we're told to do is set this equal to 0. So I'm going to pull my 4x minus 4 over, or 4x plus 4 over to the left-hand side, giving me x cubed plus x squared minus 4x minus 4 equals 0. Now, there's nothing common to all four of these terms, but what we can do is we can regroup. So I'm going to look at the first two, and I'm going to take an x squared out of it. So I'll have x squared times the quantity x plus 1. And the second one, I'm going to take a minus 4 out. If there's a minus there, you've got to take it out. So I'll take a minus 4, and that would give me times x plus 1, because when I multiply back, when I distribute back, I get minus 4x minus 4. So that's equal to 0. Now, in regrouping, if I had 2x plus 4x, that's 2 plus 4x, right? So I have my common factor of x plus 1 in this case, and I can regroup and make the, I can put the x squared minus 4 together, and that gives me those two factors equal to 0, which means x squared minus 4 would be x equals plus or minus 2, or x equals negative 1. So those are my three possible answers. And once again, I need to plug them back in to see if they work. Check your solutions. They do in this case, so we're not going to spend time doing that. I leave that up to you, so go ahead and do checkpoint 2. Okay, radical equations, everybody's favorite. Here are the rules, or the steps. Isolate the radical on one side of the equation. Raise both sides to the nth power. So if you are, if it's the square root of 2, you'd raise both sides to the second power. If it's a square root of 3, you'd raise both sides to the third power. Okay? And then solve and repeat steps 1 and 2 if there is still a radical. And we're going to show you, I'm going to show you a couple instances where you have a radical left over. Then you have to do this process twice. Okay, and then check for extraneous solutions. If you're going to have an extraneous solution, it's going to happen in one of these problems. Okay, so here's the example. Solve square root of 2x minus 1 plus 2 equals x. So the first thing we're going to do is move the 2 to the other side. So we'll have square root of 2 minus 1 equals x minus 2. Easy enough. Now, I've got the radical all by itself, and it's the square root, so I'm going to square both sides. When I square a square root, I just take the hat off. I just take the square root sign off. And that's going to be, when we do this, it's square the first term, x squared, multiply the two terms together and double them, so that'd be minus 4x, square the last term plus 4. Now I want to move these guys over to the right-hand side because I need to set the whole thing equal to 0. So I'll have 0 equals x squared minus 4x minus 2x plus 4 plus 1. And when I put those, because I've moved my 2x plus, minus 1 and made it minus 2x plus 1. So 0 equals x squared minus 6x plus 5, or x minus 5 times x minus 1, which gives me x equals 5 or x equals 1. So there's my possible solutions here. Now I need to check them out. So I'm going to start with my 5 and see if that works. So 2 times 5 is 10, 10 minus 1, plus 2 equals 5. So I'll have square root of 9 plus 2 equals 5, 3 plus 2 equals 5, 5 equals 5, so x equals 5 works for us. Let's try the other one. When we plug in 1, we'll have 2 times 1 is 2 minus 1 plus 2 equals 1. 1 plus 2 equals 1. That doesn't work because 3 is not equal to 1. So x equals 1 is an extraneous root. We have to just disregard it. So the answer is just 5 here. Okay, go ahead and do your checkpoint number 3. Okay, example number 4. When we have 2 radicals, so we have to go through this process twice. Okay, so if I have square root of 3x plus 1 minus square root of x plus 4 equals 1. You can use either one of those radicals, but I'm going to choose to move the square root of x plus 4, or the negative square root of x plus 4 to the other side. So, square root of x plus 3x plus 1 equals square root of x plus 4 plus 1. Now we have this by itself, and it's just a square root, so we're going to square both sides. When I square a square root, I just take the radical side off of it, so I'll have 3x plus 1. This, the right-hand side is binomial expansion, so we square the first term, which gives us x plus 4. We multiply the two terms together and double them, which is going to give us plus 2 times the square root of x plus 4, and we square the last term plus 1. Now we need to move everything that is not associated with the square root over to the left-hand side. So this is going to be, we're going to keep the 2 square root of x plus 4 on one side. So we'll have 3x plus 1 minus x minus 4 minus 1 is 2 square root of x plus 4. Clean this up a little bit. We have 2x minus 4 equals 2 times the square root of x plus 4. Now, I choose to go ahead, I have a common factor of 2. I'm going to divide everything by 2. You wouldn't have to. You can go ahead and work it this way, but I prefer to make things as simple as possible. So I have x minus 2 equals the square root of x plus 4. I have my square root of x plus 4 by itself, that radical by itself, so I'm going to square both sides. I'll have x squared minus 4x plus 4 equals x plus 4. See how this is getting easier and easier all the time? Putting things together, I get x squared minus 5x equals 0. When I put the subtract 4 and subtract x. So I factor this, x times x minus 5 equals 0. So that means x equals 0 or x equals 5. Well, we need to check both of these. So let's try 0. 0 plus 1 minus, back up. Square root of 0 plus 1 minus square root of 0 plus 4 equals 1. So I have 1 minus 2 does not equal 1. So I'm going to have to disregard my x equals 0. My second one, my 5, 15, square root of 15 plus 1 minus square root of 5 plus 4 gives me square root of 16 minus square root of 9, which is 4 minus 3, which is 1. So this one works. So my only answer here is x equals 5. So go ahead and do your checkpoint number 4. And you are done with this one. There's the baby. Bye, folks. Make sure that you write down what you don't understand so we can discuss it in class. See you later.